All right, welcome back, guys. So this is the last video we're gonna have for lesson 8.1, introducing the basic concept of hypothesis testing. So, after you say the claim, you go through the null hypothesis and then the alternative hypothesis, and then you look at the sample data and see if the sample data, agree with the null hypothesis or not. If not, we reject it. If yes, we support it, and then we get to the final step. That will be the conclusion of the hypothesis testing. So there are two possible conclusions that we can have in any hypothesis testings. One is that if the null hypothesis is rejected, then we conclude that there is sufficient evidence to support the alternative hypothesis. Or if the null hypothesis is not rejected, okay, if the null hypothesis is not rejected, then we conclude that the data do not provide sufficient evidence to support the alternative hypothesis. And then in this class, we always want to tie it back to what was the original claim, what was the claim that the author is making, or the person in the article is saying. So whatever our conclusion would be, whether we reject the null or not reject the null, we want to bring it back to the original claim and make that decision. So just to explain the first conclusion for hypothesis a little further, this saying that if the test statistics or the sample data, okay, is calculated and then found to be statistically significant, meaning it is way past the cutoff value that we are assigned, then that means the null hypothesis is not supported. So we're gonna reject the null hypothesis, and the null hypothesis is denoted as HO, and we reject the null hypothesis and favor H1 or the alternative hypothesis. Okay, we favor the other hypothesis. That's what the alternative hypothesis is. Second possible conclusion for hypothesis test: if our test statistics is not significantly high or not statistically significant or is not outside or cutoff values, then we don't have enough evidence. We're gonna say we don't have sufficient evidence to reject the null hypothesis. So it said that then the decision is to fail to reject the null hypothesis. Okay, if we fail to reject the null hypothesis, we do not favor the alternative. Okay, so if we reject the null hypothesis, then we're gonna go with the other explanation. And if we don't reject the null hypothesis, then we cannot favor the other explanation. So it's either support the null or support the alternative. It's one of those two things. Okay. There's a note here. It says that although a hypothesis test never proves that either hypothesis is true. Notice that we can't really prove anything is true. It's just a simple random data selected from the population. It doesn't prove anything, but we use that as our basis to make a decision. So it says that hypothesis test never proves anything is either true or false. It can only say that either the evidence is strong enough to contradict what the null hypothesis is and favor the alternative, or else it's not strong enough to reject the null hypothesis. So never is 100% true. We don't say the word we accept the null, we think the null is true. We just say, okay, based on the sample data, we have enough evidence to support what the null hypothesis is saying or not. Okay, but never 100% accept that is true or say that is false, because the evidence is not, it's just a simple random sample, not the entire population. Just like in anything else, there's always mistakes or errors in any decision making. When it comes to hypothesis testing, we have two types of errors. We have type 1 error and then we have type 2 error. And the definitions say that when we look at the evidence and then the evidence point to say, okay, the null hypothesis is not true or not support, sorry, then we reject the null hypothesis, but it turns out, okay, maybe we have a bad evidence and the null hypothesis is actually true, right? So there's a mistake we're making there. Or type 2 said that we fail to reject a null hypothesis when it's not true. Okay, so two possible error. So type 1, rejecting the null hypothesis when it is in fact true. Type 2, fail to reject a statement when it's in fact false. Okay, so just like in a trial, when you have a person on trial and that person is indeed guilty, but the jury can't find enough evidence to convict the defendant. So the jury let the defendant go, but that defendant is certainly guilty, and we just know it. But the jury can't find enough evidence to that. Just anything in life when we make decisions based on data or statistics, there's always mistakes involved. So in this lesson here, there's two type mistakes: type 1 and type 2. Here's an example. Hopefully this example makes sense when it comes to identify a mistake in a decision making. So in this example, we have a student is scheduling class for next semester. So students will sign up for class next semester, and this student is currently enrolled in English Composition 1. Okay, and the student is scheduled to sign for English Composition 2. Okay, so here's where things kind of get interesting here. It says that a potential problem arises during pre-registration. The student has not finished Comp 1, and this is usually how it is. So he needs to use the evidence that he has, which is his grade so far, to draw a conclusion whether or not he will pass the current class Comp 1. We're going to go ahead and give the student benefit of doubt, assume that he will pass Comp 1. So here's our two hypotheses here, or no hypothesis. We're going to say, okay, the student passes English Composition 1, and then the alternative is the student does not pass Comp 1. Okay, so when the student, what we can do here is we can say, okay, well, let's look at the student's current grades. Okay, so this is the evidence here, right? So suppose that the students, so if the student's current grades so far are mostly Fs. Okay, then we might say the student will not pass Comp 1 and sign him up for the same class. Okay, well, what could be possibly a mistake here? Well, a mistake would be, right, his final grades comes around. Okay, suppose his final grade for the class is a C. Well, then we made a mistake, and this happened all the time in real life. The student will have to correct his schedule, right? So there's a mistake there, right? Type 2 mistakes is very similar to that as well. I'm not going to write this out here, but suppose we look at the students' current grades and they're all, looking good, all C, all passing so far. So we say, okay, let's go ahead and sign the student up for Composition 2. And then later on we find out that he did not pass his Comp 1. His final grade come around, and then he got an F in Composition 1, and we're going to have to correct his schedule and make him repeat for Comp 1. So that's the type 2 error is a fail to reject the null, meaning fail to reject this here, because based on the evidence that his grades is passing so far, we're not going to say he's not going to pass class. But then when it is in fact false, when his final grade come around and said, oh, you got an F in Composition 1, so therefore we have to correct your schedule, turned out you did not pass a class. So the mistake was we assumed that he would pass a class based on the evidence that his grades are good. All right. In general, we can actually summarize the type 1, type 2 so far. So we have the reality, and then we have the decision. Okay. All right. So in the reality, we can either have the null hypothesis being true, or the null hypothesis is false. Decision, we can have either we reject the null hypothesis, or we fail to reject the null hypothesis. Okay. Okay. So suppose we reject the null hypothesis. Okay, so suppose we reject the null hypothesis. That's our decision, whatever the test we're doing. And then it turns out the null hypothesis is true because our evidence sucks. Our evidence point towards, okay, the null is not, we're going to reject the null because our evidence is sufficient. And it turns out later on that the null hypothesis is true. Then in this case here, we make mistake. So this mistake is called type 1 error. Okay. A type 2 error would be, okay, we just don't have enough evidence to reject the null hypothesis. We can't really, fail to reject, sorry. Okay. We failed to reject the null hypothesis, but it turns out that null hypothesis is false. So that's a second error. So this is called type 2 error. Okay. The other decision would be, okay, we reject the null hypothesis. Because it turns out that the null hypothesis is false. So we made a correct decision. Similarly, we fail to reject the null hypothesis because the null hypothesis is true. Well, that's also a correct decision. Okay. So how do we do this? How do we use statistics to avoid these mistakes? The type 1 error is when we reject a statement that is indeed true. Well, that there, we call this here, we can control this probability, okay? The probability of making type 1 error is called the significant level. Okay. And the significant level is what we already know by, that is alpha. Okay. So we can control alpha, we can assign a value for alpha. We want to make sure that, okay, what will be the likelihood that we make these mistakes? We're going to reject something that is true. Well, let's assign alpha, and alpha usually pretty standard. Alpha usually is, 0.05. Most practice use 0.05. Or sometime, you can decide. Okay. If it's not giving the problem, you can decide. Okay. Well, what will be the probability of making type 2 error? Well, type 2 is the probability of making type 2 error. This is called beta. Beta is the probability of making type 2 error. Okay. So it turns out that usually people want to lower the probability of making type 1 error, but then alpha and beta is kind of acting in a way where, the two kind of go hand in hand. If we minimize alpha, the significant level, then there's a higher probability that beta might occur. So we want to make sure that, pick the value of alpha in a way that doesn't really increase the chance of making beta, which is type 2 error. Okay.